Moving on, we are to look at the next rule, that is the quotient rule. It's the opposite of the product rule. If you refer to the formula on the left, you have a to the power of m divided by a to the power of n. So if you refer to the base on the numerator and the denominator, the first condition is they should be the same. So in this case, you have the same base as a, and they are being divided. So division is the inverse operation of multiplication. So if you are to look at the right, you are to use m minus n is the inverse operation of addition. So let's look at your first example, and let's determine this. You have 6 to the power of 4 over 6 to the power of 2. So let's check if that satisfies the two conditions we have. So your numerator has the base 6, so as the denominator. So you apply the first condition. And secondly, they are being divided, right? And that should equal to the same base, 6. And you are to do the subtraction of the powers. Take the numerator power as 4 minus, because we are doing division, that is 2. And let's simplify the result we have. So base remain as base. 4 minus 2 gives you 2. So 6 squared. Moving on, we have 2y to the power of 6 over y to the power of 4. If you can see, there is a 2 on the numerator, and we do not like it because we want y to y. So we are to remove the 2 away. We are to deal with it separately. So let's separate them. So 2, you can rewrite 2 as 2 over 1 times your y components. You have y to the power of 6 over y to the power of 4. And let's look at the number 2 over 1. That should give you 2. And y to the power of 6 over y to the power of 4. You first should check that they should be the same base, y and y, right? And they are being divided. So you are to take y as the base, same base as y, and then you are to perform subtraction. Your numerator as 6 minus 4. So you should get 2y squared. Moving on, we have two more complicated questions, but it's okay. If you see this question on the left, we are to separate the components we have. So firstly, you should have the numbers by itself, so 3 over 2, and we have the y components, y squared over y, and we have the x components, x cubed over x squared. Numbers is fine, so numbers you put 3 over 2. Let's look at the y component. So if you are referring to the base, y and y, same base, right? Apply the first condition and being divided, so you are to subtract the powers. So you have y 2 minus 1. And that's your y component. You have your x component. So check for the base, x and x, same base, being divided. So you put the same base x, power from the numerator, 3 minus denominator. And you are to simplify that. I believe the number remains as number. And you have y, 2 minus 1 gives you 1, so y. And x, 3 minus 2 gives you 1, so x should be your answer. The last, we have another question. In the same way, we are to separate each component. So you should have the numbers 12 and minus 3, and you have your a component, a to the power of 6 divided by a to the power of 4, and you have your b component, b squared over b squared. Let's simplify the number. 12 divided by minus 3. I believe that gives you minus 4. And we have the a components. So check for the base. I believe they are both a and being divided. So base a, use the power on the numerator minus the one from the denominator. In a similar way, you check b, same base, being divided, so subtract the powers, 2 minus 2, and we are to perform the simplification. So minus 4, a, 6 minus 4 gives you the power 2 squared, and b, you have 2 minus 2, that is 0. And let's rewrite b to the power of 0 as 1. We have not learned this rule yet, but you just need to remember any non-zero base to the power of 0 will always be 1. And b here, we assume is a non-zero base. So anything to the power of 0 will give you 1. So minus 4 a squared will be your answer.